As adults, we readily engage in mental simulation when choosing between options, like when trying to decide whether to walk or take the bus to work during rush hour on a rainy day. But little work has investigated how children approach problems where they are faced with a choice between alternative courses of action, particularly the extent to which they spontaneously engage in mental simulation. This research aims to examine the developmental changes in the use of mental simulation and to investigate the influence of resource availability on the tendency to simulate. We plan to test 4 to 7-year-old children using a computerized vertical maze task where children will complete 2 blocks of 20 unique trials. In block 1, the aim of each trial is to get a single ball into a goal at the bottom of the maze. So an effective way to solve this task is to mentally simulate the path the ball would take if it was dropped into each of the different entrances. So in this case, the correct entrance is the green one on the left, whereas dropping the ball into either of the other entrances leads to it becoming trapped at the bottom of the maze. But each trial will record success, whether or not the ball reached the goal, as well as response latency as a proxy for mental simulation. And at the end of the block, we'll ask children about the approach they used and code their responses as being indicative of mental simulation or not. We expect that trial success will be predicted by age, response latency, and the reported strategy used. In block 2, we'll examine whether the tendency to simulate versus explore is influenced by resource availability. So here the aim of a trial is to fill the goal with 3 balls, and ball availability will be manipulated between participants. So in the 3-ball condition shown here, participants are given the minimum number of balls required to solve the task. So to succeed, they need to work out which is the correct entrance before dropping any balls, because if they get one incorrect, they no longer have enough balls to solve the task. In the 5-ball condition, there are surplus balls for completing the task. So here there's scope for exploration. You can try out the different entrances to work out which leads to the goal and still have enough balls to succeed. So for this block, we'll also measure the number of balls used in the 5-ball condition as a proxy for exploration. And here we expect that to find longer response latency in the 3-ball condition, and that older children will use fewer balls than younger children. We welcome any feedback on our research plan. Thanks for listening.